Welcome to my channel. So now in today's class, we have to discuss with that what is the difference between the Apiori and FP growth algorithms. So these are the two algorithms you have to use in market basket analysis. So particularly, we have to arranging the data, frequent item sets in real-time environment. So these are the two algorithms you have to use in market basket analysis. So what are the differences between the Apiori and FP growth algorithms? Here we have the differences between the Apiori and FP growth algorithms. Apiori algorithm is proposed by the R. Agarwal and R. Srikanth in 1994 for finding the frequent item set. For example, you have the use items you have to purchase in a particular store. So most of the customers, they have to purchase different items. What are the common items you have to purchase it by the people? Those customers item sets. So which people are commonly they have to purchase, that you have to identify with these algorithms only. So here in Apiori algorithm, mainly you have the two phases. One is the generate phase and the second one is the prune phase. Generate phase is also called as join phase. Mainly, particularly in this phase, candidate k plus 1 item sets is generated using the k item sets. So generally here we have to generate the candidate set. We have to generate it by using the generate set. And next one is the prune set. As the prune set is generated the large frequent item sets using the minimum support at the pruning parameter. So this is the regarding to the Apiori algorithm. So here, what are the advantages and what are the disadvantages of Apiori algorithm? So here we have the advantages is we have the large item set as well as easy to you have to implement and as well as parallelized. So number of candidate sets we have to parallelly we have to generate it. That is the major advantage of Apiori algorithm. What is the disadvantages? So here you have the disadvantages. Here you have to generate the huge number of candidate sets. So its generation is expensive and transaction database is memory restrained here, and the support count is expensive because it requires many database scans. So number of scans you have to generate it in this algorithm. So these are the disadvantages of Apiori algorithm. What is the FP growth algorithm? So here you have the Apiori growth algorithm is simply you can say that it is proposed by the Han. An efficient and scalable method you have to minimizing the mining the complete set of frequent item set by pattern growth fragment growth using the extended prefix tree structure for storing compressed and crucial information about the frequent parameters named as frequent pattern trees. That is simply you can use FP trees. We have to use it here. Here, what are the steps in FP growth? Mainly, you have the two steps. First one is the database showing the frequent item sets in FP tree is build passes over the data set. Only two passes we have to perform it here. It divides the FP tree as a set of conditional databases and mines the each database separately. And here you have to generating the easily you can FP trees. You have to once you have to construct it automatically. You have to use it in null based route you have to define, and the number of ways you have to representing the count the number of items we have to generate the using linked list. So here, what is the what are comparing with the Apiori and FP growth algorithms? So here we have the advantages of FP growth algorithm. It compresses the database and also it only requires only two passes over the database. But whereas over there you have the number of passes. in Apiori algorithm. Here, no candidate generation, candidate you have to generate it in FP growth and faster than Apiori algorithm, and it reduces the success cost. These are the advantages of FP growth algorithm. And what are the disadvantages is it may not fit the main memory. Why? Because you are using the linked list. That's the reason it not may fit the main memory. And FP tree is expensive to build because it obtained easily. Once build a frequent item set, once a tree you have to generate it, so automatically the frequency is obtained easily. And support can be only be calculated once the entire data set is added to FP tree. These are the disadvantages. What are the advantages of Apiori and what are the disadvantages? Similar way, FP growth advantages and disadvantages up to now we have to discuss. Now see the based on parameters we can divide the Apiori algorithm and FP growth algorithms. Here the technique Apiori priority property and join the prune property. Here we have to use the two properties. So you have to use join and prune properties or generate or prune properties. Whereas in FP growth, it constructs the conditional frequent pattern trees and a conditional pattern based from the database which satisfy the minimum support. And compared to whenever you want to discuss the memory utilization, due to large number of candidate generations requires the large memory space in Apiori algorithm. But whereas here, due to compact structure and no candidate generation requires less memory. And a number of scans, multiple scans for the generating candidate data set here. But whereas scan the database only twice and twice only here. Compared to the time, the execution time is more as time is wasted to producing the candidate every time. But whereas here, the execution time is lesser than the Apiori algorithm. So these are the major differences between this Apiori and FP growth algorithms. So now I want to discuss with that examples, Apiori algorithm example, as well as I want to take one example, and I will differentiate the both the how to processing the problem in Apiori as well as FP growth. First, this is the problem you have to consider. In that problem, it consists the 8 transactions here. See here, this is the major first problem. Transaction IDs, list of items. So one customer may have to purchase the bread, milk, sugar, tea powder, cheese, tomato. So like this, 8 transactions there. You have different people, they have to purchase their items. So based on these items, I want to find out the frequent item set using the Apiori algorithm. Similar way, I want to find out the frequent item set using FP growth algorithm. So for the same item sets, I want to apply the both Apiori and as well as FP growth algorithms. Once we have to check it out, this is the so in this problem we have the 8 transactions. So in 8 transactions we have the totally 8 transactions. They have to purchase their items. Based on these items, you have to find out the frequent item set using Apiori algorithm. First, to count the number of transactions. How many transactions you want to perform? So that is the 8 transactions. And second step, we remove all the items. They are bought less than 2 times from the table. And ఇక్కడ ఎక్కడైతే 2 times కన్నా తక్కువ ఎవరైతే పర్చేజ్ చేస్తున్నారో those items you have to remove. So here, see here, this is the support count. First, bread you have to consider. This is the bread. How many times they have to purchase it here? Bread here, here, and here, and here. So totally 4 times they have to purchase it in 8 transactions. So you can write the support count is 4. Similar way, milk. How many times they have to purchase? So 7 times. So like this way. All items information you have to write here is the support count you have to retain here. Where the compare, now you have to compare and pruning the step. Where the grade less than 2 items are there, you have to remove those items. So I want to remove those items here. Bread is 4 times, milk is 7 times, sugar they have to purchase 3 times, cheese, tomato, onion, chilies, cake, biscuits, jam, butter, paneer. So these are the items they have to purchase greater than 2. Who is the less? Which items are less than 2? Less than 2. Those items you have to remove here. So this is the first one, candidate generation, and the next candidate generation 2. Now 2 items. Now we have to only one item you have to consider. Now we have to consider a group of 2 items. First item you have to consider here, that is a bread. Bread you have to bread and milk. How many times you have to get it? So how many times they have to purchase? So now we have to see here, bread and milk they have to purchase it 3 times, and bread and sugar they have to purchase it 2 times. Bread and cheese 1 time. Bread and tomato 2 times. So like this way, you have to generate the candidate generations in C2. You have to generate it. Bread jam 2, bread buffer 1 time, milk sugar 3 times, milk cheese 3 times. So in these all candidates generations, those which item sets are less than 2, those items you have to remove. So see here, that is the removing, that is here. I want to remove here, compare and prune. So we have to remove all less than 2. What are the item sets you have? That those item sets you have to remove here. Bread, milk 3, support count is 3. Bread, sugar 2. Only 2 and 3. Only those support count I have. Only we have to consider. After consider those item sets, now you have to generate the candidate generation 3. So now 3 items we have to take in as item sets: bread, milk, sugar. So you can write the bread, milk, sugar, how many support counts. So you have to consider 2. Where the items now you have to compare and pruning. So where the 2 items, 2 support count are there, only those are only considered. So milk, sugar, chilies only 2 times they have to purchase in 8 out of 8 transactions. So that only you have to consider. So where the 2 support count is 2, that only consider. Remaining less than 2, you have those item sets are you have to remove. After removing, here, so here where the support count is 2. So above after candidate generation 3, whenever you want to generate here, generated whose minimum support is less than 2, so it is not frequent. That's the reason here you have to consider brought together more frequently. These items only they have to frequently they have to purchase it. These are the item sets for using Apiori algorithm. Bread, milk, sugar, bread, milk, chilies, milk, sugar, tomato, milk, sugar, chilies. These are the frequent item sets you have to use to finding the using Apiori algorithm. And the next one, you want to write here. I want to write here. You want to write whenever you want to generate using the Apiori algorithm. First, we have the 8 transactions that only you have to consider. First, you scan the database, determine the set of frequent items, their support counts. So first one, how many support counts are there? First, you have to write down greater than 2. Those items only you have to consider. So here you have to first you have to write down. Milk is support count is 7, and 7 times you have to purchase. Bread 4, chilies. In ascending descending order, you have to write the all the items its support counts. Now you have to consider the linked list. So first you have to taking the one root node, that is the null node. From the null node we have to consider its the support count is 7. So each transaction you have to consider. See here, only few steps you have to complete it. Here we have the first transaction you have to consider. Bread is first null set you have to consider. In the null set, first transaction you have to consider bread. So bread is here you have, that is the bread you have to assigning as 1, and second one Second one is the milk. Milk is represented as 1. Sugar is represented as, again you have to call with the sugar is 1. And the next one, tea powder, you don't have that item set, so you have to left out. And the next one, cheese. Cheese only we have to consider here. Cheese is taken as 1. So like this way, next tomato you have to consider here. You have to represent it as 1. Okay, next one. You have to take the second transaction. In the second transaction, first one is the onion. So already, if any one of the link you have to connect it or not, you have to check it out. No, onion is separate. So you have to connect it with that onion link is taken as 1. Next one, tomato. Tomato already linked with node link. We have to connect it with this subnodes. So whenever the subnodes we have to link it, this is the tomato. Tomato we have to, that is the position we have to change it to 2. Okay, like this way, all transaction we have to process it. You get the all whenever you have to have the milk, you get the the support count is 7. Bread is taken, you are getting the 4. Chili is 4. Like this way, we have to getting the all subnodes we have to fill. So this is the FP growth algorithm. So this is the difference between the FP growth and Apiori algorithms. Thank you for listening. Please subscribe my channel.